we'll move on to a couple more challenging ones. So one of the first ones that I'm going to take a look at with you is going to be x squared minus 4x minus 45 is equal to 0. So note that now we have an equation because specifically we have the equation set equal to something. And as we discussed in class previously, you want that equation to be equal to 0 because it actually limits the number of choices that you have to work with in order to solve for the variable. So in this particular case, you notice that we do have a trinomial on the left-hand side. And from what we have been covering in class and what you've been training for, you want to go to the side of trying to factor it down. If you're able to factor it down, it basically breaks things down into smaller pieces, which allows you to solve for that variable. So in this case, usually when I see a trinomial, I'm fairly confident that it's going to break into a product or a multiplication of two binomials. If you need to, you can go ahead and create your box in order to do the box method. So first off, we have x squared, which will go on the top left. And I know that x squared can break into x times x. The next one that we're going to take a look at will be the minus 45 here. So that will go in the lower right. And basically, you have a couple questions that you should be asking yourself when you're trying to decide how to break this up. I mean, of course you can do trial and error without really putting a whole lot of thought into it, but if you start asking a couple of questions ahead of time, it'll just start to help you limit what choices you have to sift through. So in this case, I do have a minus 45, and I also want to note that the middle term is also a negative. So I do know that one of the values that I'm going to have will be a negative, and another one will be positive. That's the only way that I can get a constant term, in this case the 45, to be negative. I also want to note that since the middle term is negative, it must mean that between the two numbers that I pick that multiply together to give me negative 45, when I add those same numbers together, I should get a negative number out. In other words, that means that the negative value will be the larger number. So if we're going through and we're trying to decide, well, what two numbers multiply to give you negative 45, maybe, for example, that would be 9 times 5. And again, since the middle term is a negative, maybe that means that I should make the 9 negative and the 5 the positive. And again, the box method is there to help you make sure that your choice is correct. So in this situation, x times negative 9 would give us negative 9x, and then x times 5 would give us positive 5x. We can double check our work here. If we were to sum this, this is equal to negative 4x, which matches the middle term that we have here. So that means that I do have my final solution. I have x minus 9, and then x plus 5. Note that when you are looking at these two binomials that we have here, they have been factored down as far as possible. I know in previous sections we were talking about the difference of two squares. You may notice that the 9 is a perfect square. We do have a subtraction, but note that the x is not being squared. It is just one single variable. So that means that I cannot break this down further. I have to leave it alone. So now we can say, well, if the quantity of x minus 9 times the quantity of x plus 5 is equal to 0, then that means that either that quantity of x minus 9 is 0, or that quantity of x plus 5 is 0. This allows me to solve for x. So x could be equal to 9, or x could be equal to a negative 5. So I do have two solutions here. And again, if you wanted to check to make sure that you had done this correctly, you would plug both of these values separately into the equation. So your check, I won't actually go through it all the way, but your check would be 9 squared minus 4 times 9 is equal to minus 45 is equal to 0. You would want to check to make sure that it does actually equate to that. And you would also want to check negative 5 squared minus 4 times negative 5 minus 45 is equal to 0. If you have some time, I would encourage you to check it to make sure that we did do that correctly. Okay, so another problem that I would suggest will be the following. Let's try 16a squared is equal to 49. Again, in this situation, we do want to make sure that everything is set equal to 0 first. So what I would suggest doing is let's remove a 49 from both sides. So this is going to give me 16a squared minus 49 is equal to 0. So again, we do want to make sure that we can factor this down. And one of the first things that I'm noticing is that between the two terms is a minus sign. Also notice that 16 is a perfect square. A squared is a perfect square, just by the very fact that it is a variable being squared. And we also can see that 49 is a perfect square. So if we were to go ahead and break this down, you may use the box method if you need to, or at this point maybe you can just use the guess and check or trial and error. But what number can multiply by itself to get 16? That would be 4. A squared we can split between a times a. The negative 49 means that we would have a plus 7 and another one be minus 7. In this case, remember that we call these two values conjugates. Impress your friends for later. So again, notice that we have these broken down into two prime polynomials. I cannot break them down any further. Yes, we do have a minus sign, but again, try not to go on autopilot. Notice that 7 is not a square of any other number. 4 is, but it is attached to a single variable a, not an a squared. So the very fact that you just have that 7 there, that it is not the product of two perfect, or not the product of the number in itself, means that you have to stop. You can't go any further. So again, we have 4a plus 7 could be equal to 0, or 4a minus 7 could be equal to 0. So we can subtract 7 from both sides in this case. We have 4a is equal to negative 7. Divide both sides by 4, and in this case a is equal to negative 7/4. Or, in this other case, we can add 7 to both sides, divide both sides by 4, and we get a is equal to 7/4. So it is completely fine and sometimes expected that your final solutions will be fractions. While you may not be best friends with fractions, the fact of the matter is that sometimes your answers are going to be fractions. It's no big deal. Okay, so let's look at something a little bit more challenging. And by a little bit more challenging, I really do mean slightly. So let's go ahead and take a look at the following question. We're going to take a look at 5x cubed is plus 13x squared is equal to 6x. We have to do a little bit of manipulation before we can actually solve this. Remember that before we want to solve any of these, we want it set equal to 0. In this situation, I'm going to subtract 6x from both sides, and I am deliberately going to have this written in a descending order. So recall that descending means that the degrees are going to tick downward. So here the first term has a degree of 3, the second term has a degree of 2, and if you really need to see it, the third term has a degree of 1. So it's descending. Those degrees are ticking down. Okay? So the next thing that I want to note is that each term has an x attached to it. So this actually works to your benefit. So I'm going to pull a single x out of each term. And this leaves me now with a 5x squared plus 13x minus 6. And again, that is equal to 0. So we can go ahead and use our box method in order to help us out here. The 5x squared will go in the top left. The negative 6 will go in the bottom. We may need to kind of go lightly here. Again, the box method is not a guarantee that you will have the correct answer on the first try, but it does help you graphically organize your thoughts. So 5x squared, I know that I can break this into a 5x and a single x. Okay. So now, again, we do need to kind of take a look here and notice that our third term is negative, but our middle term is positive. So that must mean one of these values that I'm going to break negative 6 into, one of them must be positive, one of them must be negative. And I need to work it in such a way that when I do my check, in other words, when I take a look at this, they need to sum up so that I have a positive value. Okay? So in this situation, I would say, let's try putting a positive 3 here and a negative 2 here. So here's my thought process behind that. I do know that a negative 2 times a positive 3 is going to give me a negative 6. I also know that 5x times a 3 will give me a positive 15x. So it's going to make it very large, but this is a very large positive value. And then the x times the negative 2 is a very small negative value. And just enough that if we take that 15x plus that negative 2x, it does leave me with a positive 13x. If you didn't get that on the first try, that's not a big deal. Again, it's trial and error, it's experience, it's practice. Factoring is going to come to you through a lot of practice, not necessarily an easy thing. Okay, so we do have our final answer. So let's go ahead and piece it together. Never forget the x that you factored out initially. And this is going to follow with an x plus 3, and then a 5x minus 2. And we know that this whole product here is equal to 0. Note that you do have 3 terms here. You do have, or 3 factors. You do have an x, you do have an x plus 3, and you do have a 5x minus 2. You do not want to forget any of those when you are putting together your final solution. So that means that x could be equal to 0, x plus 3 could be equal to 0, or 5x minus 2 could be equal to 0. The good news is, look, this one is already done for you. X could be equal to 0. With a little bit of work here, we can see that x could be negative 3. And with just a couple of steps, we can say that x could be equal to 2/5. There are those fraction answers again. Can't escape them. So here are your 3 possible choices. Again, recall from class that the tip-off that you will get 3 answers is the degree of the polynomial that you are working with. Remember, the degree of the polynomial is the largest degree that you see. In this case, the degree is 3, so that will indicate to you that there will be 3 solutions. Okay, so one more, because I know that you all are having so much fun, and who am I to deprive you of said fun? Let's go ahead and take a look at the following. Let's look at negative a to the 4th minus 36 plus 13a squared is equal to 0. Now, this one is a little bit messy. It's a little bit jumbled, so you do have to clean it up. So one of the first things that I'm going to notice is I want to write this in descending order. So I will do a negative a to the 4th plus 13a squared minus 36 is equal to 0. Note that I did keep the sign that is directly out in front of the term with it. Okay, that is important. Okay. So the next thing that I'm going to notice is I don't like the fact that there's a negative in front of my lead term here. So what I'm going to do is I'm going to factor out a negative 1. So that is going to leave me with a positive a to the 4th minus 13a squared plus 36. And that will be equal to 0. So notice that by factoring a negative 1 out, each of the signs in front of the terms changes their sign. If you distribute the negative 1 back into your quantity, you will get back to this previous step. Okay? So let's continue. So the negative 1 is going to just stay out there. We don't really need to worry about it anymore. It's just going to go along for the ride. But let's see if we can go ahead and factor what we have in that quantity. Okay, so we know that a to the 4th will go here. We know that 36 will sit here. And I know that I can break a to the 4th nicely into an a squared and an a squared. And we need to figure out the 36. Notice that, again, the 36 is positive, but the middle term that we're going to have is going to be negative. So that tells me if I'm going to multiply to get a positive number, but I'm going to add them to get a negative number, that means in this case both of my values will be negative. And we need to think of a way in order for two values that multiply to get 36 will also add to give me a negative 13. So take a moment and think about that. Maybe pause the video. If you come back, I would suggest let's try 9 and let's try 4. So negative 9 times a squared is negative 9a squared. Negative 4 times a squared is negative 4a squared. Okay, so if we were to add these up, we do get a negative 13a squared. So the good news is that we are almost done. We have negative 1 times the quantity a squared minus 9 times the quantity of a squared minus 4 equals 0. So now, if you are noticing, I do have a perfect square in both of those binomials. A squared can be split apart evenly. We also note that 4 and 9 are both perfect squares. 3 times 3 gives you 9, and 2 times 2 gives you 4. So I can break this down further. Again, the negative 1 just goes along. And in my first situation here, this quantity of a squared minus 9 can split into a minus 3 times a plus 3. And then in my other case, this quantity of a squared minus 4 can be split up into a minus 2, a plus 2. And this is all equal to 0. If you need to use the box method in order to determine these binomials, please go ahead and do that. Feel free to stop the video and try it out to make sure that we're all on the same page. So when we go ahead to set our final answer, the negative 1 here, you could technically say you could set it to 0, but this gives you a false statement. Negative 1 cannot be equal to 0, so let's just pretend that that never happened, okay? In fact, I will go so far as to erase the whole thing. There it goes. Never, never, never to be seen again. So we have a minus 3 could be equal to 0. We have a plus 3 is equal to 0. We have a minus 2 could be equal to 0, and a plus 2 could be equal to 0. So again, that means that a could be equal to 3. A could be equal to negative 3. A could be equal to 2. And finally, a could be equal to negative 2. So here, in this case, we have 4 different possible solutions. And again, if you go back to the original problem, the largest degree that we had was a 4. Again, it's not a coincidence that because your degree of your polynomial was 4, that you get 4 solutions out. I hope that this video was helpful. I apologize if it was a little bit long, but if you do need additional help, please let me know.